1, 2, 1, 2, 1, 2, 1, 2. Testing. 1, 2. 1, 2. Okay, I think it's working. I think it's working. Okay, great. So let us see. So here we are. So the problem, of course, with total doubling is that we cannot calculate averages for all levels of production, and that's what we're trying to do. So, I mean, I may be able to find the total time for the first 8 units, and hence the first 16 units. I can keep going, but I cannot find out what's going on with the 14th unit or the 11th unit, as you noticed in my earlier this previous video. So what if I need to find this information? How long it takes to make the 5th unit? You know, it's tricky. So again, the learning curve is useful if the output keeps doubling. So you can get questions in the exam where everything is doubling. You just do that, just follow that, like what we did in the last video. But where you have a need to find the intermediate output levels, you can get that with the formula. And what is that formula? Y is equal to AX raised to the power of B. Raised to the power of B. So let's just define what these terms are. I mean, it is this curve, really. It's this curve that we're seeing over here, where Y and this is X, your number of units. So let's see what this Y is. This Y, well, let's start with X. X is the cumulative number of units, so the total number of units that I'm interested in. Right, the total number of units. It's important to understand exactly what we're looking at here. Remember, this is about the average. I'm telling you, I can tell you a relationship between average, cumulative average, and number of units. I can tell you that relationship. And Y is the cumulative average time per unit to produce X units. So exactly the same thing. It's that relationship by, if you like, you know how I was doing 1, 2. Now I'm saying 1, 2, 3. I can tell you 1, 2, 3, 4, 5, 6. I can keep going. And I basically have my average, whatever, 10, 9, 8, 7, whatever, 6. This relationship is what this curve is looking at. The relationship between units and the average for those units. So it's not about total. I'm still going to have to work out the total. If I want the total, I'll have to multiply these two together. So this relationship is very much about averages. This relationship is very much about averages. Right. So let us see here. So and the other thing, of course, where A is very much the time, if you like, that we need to produce the first unit of output. The first unit of output. Yes. So you will always get given the time it takes to produce the first unit, because then otherwise you can't complete the curve of the equation. And oops, sorry, I've written on this. Let me just clean that out. And B, and I'm going to test this because I can do it on my own calculator. I'm going to try and use the calculator on my screen for doing questions. And B is referred to as the index of learning. So like I said to you, Y was equal to AX raised to the power of B. The question is, what is B? So you can kind of isolate B. I'm going to have to, you see, B is raised, isn't it? So this is like X raised to the power of 2 or X raised to the power of 3. That's what we're talking about, X raised to the power of B. But in terms of B, calculating B is equal to, so don't worry about, don't be frightened by the digits, is log R divided by log 2. So on your scientific calculator, you will have a log button that you will just literally plug in whatever R is, and R is the learning rate. So for example, if the learning rate is expressed as a decimal, let's say the learning rate is 90%, that's 0.9. So basically you would say log of 0.9 divided by the log of 2. It's always the log of R divided by the log of 2. And when you get that answer, that is your B. Then you now take that B and then whatever your number of units are, basically raise that number of units to that B, if you like, right? And that's kind of the point. But again, it's just practicing with your calculator to make sure you can basically get this calculation done, if that makes any sense. So I think this is a question. The first unit, you're told that the first unit of a new product takes 100 hours. So I know that my A is equal to 100 hours. That's the first thing. I'm trying to find Y. So I know what A is. Then it says an 80% learning curve is known. So I can now find B. B is equal to the log of 0.8 divided by the log of 2. Right? And the next question says that calculate the average time to make the first 16 units. So really just going back here, x is equal to 16, and I just said y is equal to ax raised to the power of b. So my task, first of all, is to find b. So I need to look at my calculator and find the log of 0.8 divided by the log of 2. So like I said, what I did was I actually, just to show you how this would work, I actually dug out my calculator. Where is it? Let's find it again. Calculator. Yeah, here we are. Disappeared. And here we are, scientific calculator. And I suspect what's going to have to happen is that some calculators you might need to type in the figure first. But I'm going to try it both ways to see do it with to do it just to show you that there's nothing tricky. So that's 0.8, and then I click log, and it gives me my answer. So again, like I say, I'm going to do it like just do it individually and then do it. I think it might be best to do it all at once because you can see that there are lots of numbers here. 0.0969. I'm just going to stop. I'm just going to take the first 4 digits and just write that down. So my log of 0.8 is minus, it's a negative, isn't it? Minus 0.9, and I'm going to clear that. Where is my clear button? Right, and I'm just going to do the log of 2. Let's see what that is, and that's 0.3010. I'm just going to 299. Oh, that's 299. I'm just going to say log of 0.3011. No, 0.10. Those 299s have kind of seemed quite a lot, so I'm going to clear this. So now I will just sort of just test it, but again, like I say, I'm going to do it both ways, 0.0969. I'm doing this the long way, shouldn't really do it like this, divided by, there's a minus, of course, here. I mean, it doesn't matter. I know it's going to be minus in the end, right? I'll start again just to show you what I mean. Where is oops, sorry, clear. Everything clear. Minus, so it seems I have to write the 0.0969. So calculators are different. And then I'll put the minus. Okay, right. So you see, it does it that way. Just following the rules of your calculator. Divided by 0.30102999 and equals to. And then I have this minus 0.32189. Okay, now I'm going to try this completely differently. I'm going to try and do it like, if you like, using the brackets and see if it lets me. So 0. Let me clear this again. Let me try this. It doesn't like it, so I have to do it. 0. Well, sorry, let me clear this. Brackets. And I'm sure, of course, again, like I say, it's about 0.8 log. I can see here this, and I'm going to do that, and I'm going to say divided by, brackets again, 2 log brackets, and let's see what happens. You see, because I'm trying to do it as one whole in one log of 0.8 divided by log of 2, and let's see what we get. Yes, it does it. So what you have to do is you just have to make sure you're happy, you understand your calculator, because ultimately I'm trying to get this figure of 0.32. You want to do it as one because it keeps all the decimals. So I now have this figure here of minus 0.3219, and ultimately I'm trying to raise this. So that's my b. This is my b. This thing is b. And remember, I'm trying to say x raised to the power of b. So it might be a good idea to store this figure in your calculator. So I guess this is kind of like, how do you use your calculator to do it? But I think, and I guess the question here is that I need to store this, and I'm going to click memory and just store that and see if it stores it. But it's 0.3219. So now what I'm going to do is I'm going to go my x is 16. So I have 16 raised to the power So this is for me, this is this button here, my XY button, raising it. So it's like take your figure, the thing you're dealing with, which is 16, and raise that to, so for example, like 16 squared. I'll go 16, then just click this button and then click what it is you want to raise it to. So I'm going to go 16. I'm going to click this raise, and I'm going to go back to my memory recall. You can see that it's recalled it for me, and I'm going to go equals, and it gives me 0.4096. So I think part of this lesson definitely is you appreciating your calculator and understanding how you can use it to arrive at the answer. I mean, a bar literally writing out the physical numbers, but the fear is you might lose a digit or two along the way. Okay, great. So you have 0.496. So now I know what x raised to, or 16 raised to the power of b is. 0.4096. I can now close this. So let's come back here. So what am I saying? I have done, so 0.4096. So I've said that y is equal to a times x raised to the power of b. I found b. B was equal to 0.301. Oh, no, wait a minute. Yes, I think it was minus. It doesn't matter. I don't remember now. Whatever it was, because I did it all at once. I suspect it was minus. It was minus. Of course it was minus. Minus 0.1, minus 0.3219. I chucked that in there, raised it to the power of, I raised x, which is 16. So I did 16 raised to the power of minus 0.3021, blah, blah, blah. And this in itself came to 0.4096. So now my y is equal to a, and I know that a is equal to 100, I'm told. And the first thing takes 100 hours times 0.4096. So of course, this means, of course, that y is equal to 40.96, right? So what does this mean? The average time to make 16 units, if you like, is 40.96. So let's just yeah, and that's kind of the point there. So that's what they wanted, 40.96. That's the average time for the first 16 units, all the 16 units. That's the point, right? And then I can find the total by multiplying 16 times that, right? And I can do the same thing, the average time for the first 25 units. So you do exactly the same thing, where you have y is equal to, I know a is 100, if you like, times x, which is 25 this time. And I have my, well, I found this. I already know now. I know what my b is. My b, if you like, is 0.3219. I'm just going to approximate that now. So literally, go to your calculator. So let me just go very quickly to that calculator again and do it. I found b already, so there's no need me doing b again. Keep. It's minus, by the way, minus 0.3219. Let me just go to my calculator again and do it. Yeah, here we are. And so I have here 25 raised to the power, again, like I said here, of 0. I'm just 3219 minus, I've noticed the calculator wants me to write the figure out there. And then I just click equals. See here you have 0.354, 0.3548. So I'll just take that. I'll take the 0.3548 from there. So this all together is 0.3548. So 0.3548 times 100 brings me to y is equal to 35.48. Y is equal to 35.48. So this is the average time it takes to make 25 units, right? And that's kind of how so I can find absolutely anything I need to find. Literally, oh, at 30 minutes, that's a bit too much. And then I can do exactly right. So I'm thinking in this video, do I do this? Yes, I'll do it in this. I'll do it in this video. So slightly long, forgive me. So just kind of clearing that. I mean, oops, sorry. So okay, it doesn't really matter. Now they want me to find the time it takes to make the 20th unit. Now, they want the specific 20th unit, so hopefully you can start to analyze what's going on here. Here's the thing. I've just said to you, right, if I know the average time it takes to make anything, I can find the total time. So the theory here is this. Well, if I want to know how long it takes to make the 20th unit, what I need to do, first of all, is to find the total time it took to make the 19th unit and the total time it took to make the 20th unit. Sorry, the total time it took to make the first 19 units. So the total time it took to make the first 19 units, all that time. The total time it took to make the 20 of the first 20 units, all that time, and find the difference, right? Because if it takes me 100 hours, let's say if it takes me 1,000 hours to make the first 19 units, and it takes me 1,020 hours to make the first 20 units, it must have taken marginal cost or marginal time 20 hours to make the the um the 20th unit, right? So what does that in effect mean? That means, and let's do it, that what I need to do is I need to find, I'll do it for 19. So I'll say, okay, let's find out what's going on with 19. Let's find the average time to help me find the total time, which is y is equal to a, if you like, x, where I know that x is equal to 19 raised to the power of b. And I'll do exactly the same thing for 20, but I'll find the total time for the 19 total 19 units, and I'll find the total time for the 20 units. Yes, sorry, this video is slightly longer, but it's kind of just because we need to do this one. So let's do 19. So 19 is telling us that, you can pause the video so you can do it yourself. So y is equal to 100 times 19 raised to the power of b. I know what my b now is, 0.3219. I will use my own calculator because it's just faster. It clicks better. 19 raised to the power of 0.3219. Where is my minus button? Quickly, Oyen, where is your minus button? And I can't find my minus button. But let's just do it again. You know what? I'm just going to use the computer, because the calculator I'm using is not the one I normally use. Okay, so we have this 19 here. And so what am I saying? I'm telling you to find out what 19 raised to the power of 0.3219 minus is. And there you have that. You have 387. So you have I'm just going to stop at 387 just because I'm teaching 387, 0.3875. So I have here y is equal to 100 times 0.3875. And so what does that mean? That means that y is equal to 38.75. That's the average time for making these 19 units. But that means the total time for the 19 units must be 19 times 38.75, right? That must be all the time it takes. 38.75 times 19. And that's 736.25. That's the total time for 19 units. Let's see what happens for 20. I do exactly the same thing. 100 times 20 raised to the power of 0.3219. Right? And so when I do that, let's just come back out here, keep this. And I have here, again, calculator. Yes, so I have here 20 raised to the power of, yes, 0.3219, and then just put that a minus, do that, and you have 0.3812. I'll just take the first four, 3812, 3812. And so what do I have here? So I now have here 100 times 3812, and that, if you like, is 38.12. You can see it's getting smaller. So 38.12 is the average time. So that means the total time for 20 units must be 38.12 times 20. 38.12 times 20, which is 762.4. So if it takes the total time for 20 units is 762.4 and the total time for 19 is 736.25, the difference, 762.4 minus 736.25, of course, must be the time it takes to make the 20th unit, right? It just is the additional time. Minus 736.25 is 26.15 hours. Yeah. So that's how we work around this. This has been a long video. Yeah, apologies. Great, and that's it. So that's really the extent of what you get. This idea of being asked to find this thing. Oops, sorry. Being asked to find the actual. You could be asked to do a number again. Like I say, you could be asked to find. I'm just trying to get to a question. Yeah, here we are. So you could be asked a number of these scenarios here. You could be asked to find just the average time to make a certain number of units, which you would just plug into the formula and find. You could be asked to find the total time. You would just multiply your answer y times the number of units. Or you could be asked to specifically find the time it takes to make a particular unit. So you would have to find the total times around that, the one before and the one of thing, and then find the difference. But to get those totals, you'd have needed to find the averages first. So slightly long-winded, but not bad. Okay, see you in the final video.